Let's take a bit of a closer look at step one of urine formation, which is filtration. In order to have filtration, you must have these two things. Number one, we must have a filter. And so remember, filtration is just passing a solution through a semi-permeable filter, just like a coffee filter or the pool filter or the furnace filter. So in the case of urine formation filtration, the filter is what is known as the filtration membrane. And the filtration membrane has two parts. It is partially the blood vessel. There are holes, right, pores in the glomerulus, which is the capillary bed that services the nephron. And that leaky capillary bed is right next to Bowman's capsule. And Bowman's capsule is also very leaky. It has filtration slits in the visceral layer. And so in other words, another way to put this is the filtration membrane is basically this leaky interface, right, between the blood and the nephron. It's leaky because there are fenestrations or pores in the glomerulus, the blood vessel, and that's in contact with this leaky or porous, the filtration slits of the nephron, the visceral layer of Bowman's capsule. And so together, the glomerulus and the visceral layers of Bowman's capsule make up the filter. So let's just take a look at the filtration membrane. We've already looked at this, but you can see the visceral layer of Bowman's capsule, those yellow cells, the podocytes, right, which are loosely interwoven together, leaving those big gaps called filtration slits. And then the glomerulus, the capillary bed underneath it, we know is porous. And so taking another look at this, we can see a little bit closer that the blood inside of the glomerulus, some of the smaller parts of it, smaller solutes, water, can pass through the fenestrations. This gray area is just a basement membrane, and then through these filtration slits and end up in Bowman's capsule. And so what happens is pressure drives substances out of the glomerulus and into Bowman's capsule. That's what's known as filtration. And the substance that enters Bowman's capsule is known as the filtrate, or people also describe this as the glomerular filtrate. Taking a look at the other requirement that we need for filtration. So remember, one, we have to have a filter. And the other thing that you have to have is you have to have a driving force. You have to have something that's going to make that solution cross the filter. And so in the case of urine formation, the driving force is what's known as the net filtration pressure. And so it's the sum of positive and negative forces at play, which I'm going to make another short video on the net filtration pressure, the different forces that go into it. But, you know, basically as a basic summary of the net filtration pressure, take a look at this. Do you notice how the afferent arteriole that's bringing blood into the glomerulus has a wider diameter than does the efferent arteriole blood, taking the blood away from the glomerulus? And so in other words, we're letting a lot of blood flow into the glomerulus, and then we're not letting all of it exit as quickly. And so what's going to happen is that's going to build up pressure in the glomerulus, and that's actually the main driving force of filtration, although there are other forces at work here, so we'll take a look at those. But that's what I mean by a driving force. In the case of urine formation, it's pressure, and it's known as the net filtration pressure.